Guys, welcome back. Well, first of all, sorry for the echo, but like it's going to be like that for a while till I manage to solve this problem in this new room. However, maybe a year or two ago, I created a video about Unreal Engine, but more specifically about random colored emissions, which kind of blew up. In my case, in my channel, that view count is really nice. So there were not a lot of tutorials on that topic, and I didn't really know what I was doing, but it was just enough for the community to have some benefit from it. So they really liked it. But now that I maybe understand it a little bit more, since like a year passed or two, maybe, I thought I can go back to that topic and have it explained a little bit more in depth and maybe recreate the whole thing. So now I brought you this scene right here. So at first, this is going to be a little bit disturbing, right? But let's have a look at it and let's explain what is going on right here. So as you can see, we have different things doing different things, right? So up there on the houses or the house like shaped as boxes, you can see those signs that we had in the previous tutorial. So this is all material driven, so we do not have a lot of control over it, but we have some control in terms of speed. That's that. We are going to take a look at that, and also, as I said, this is maybe the most complicated one because this is all material driven. Although it's really easy, but it's still the most complicated one because it's all material driven. What I would suggest you doing is to create an actor from every single instance of this sign, and then instance it yourself. So scatter it yourself. So what I do not recommend that you have some other 3D application which cannot transfer instances from whatever application you use to Unreal Engine, because if you use Houdini, this problem is probably solved because the Houdini can use Unreal Engine instances, so you can have one master um, actor of this class, and then you can have instances of that actor, which is really nice because then you can code in blueprints or like code in C sharp or C++, and then you can have a lot more control, like infinite control if you wish. But now, if you have a scene set up in another engine, in another 3D software, for example, Blender is a common one, and then you want to export everything and import it into Unreal Engine, then you might find yourself in a situation where you have 5,000 static meshes that you load into your map, which is not only bad for performance, but it's going to be hard to control every single one of them. Or you can one by one create an actor out of every single one, but that's going to take forever. So I don't recommend you doing that. So here's the thing: if you have that and you're working on like a fan art, I don't recommend this for a game. But if you're working on a fan art or you're working on some project and you need like these cyberpunk type lights, and you made this mistake, then here's your solution. You don't have to scrap your project and start all over again. You import every single static mesh in it, and I'll show you how to create with some control randomized lights. So that was the first part, and I'm gonna leave the timestamp for this one because you're probably here from the other video that I made, and you're interested in this part. Then here's your timestamp right there. You can just scroll there or forward there. So next up, we have other lights here, as you can tell. We have some nicest Halloween themed pumpkins that I put a little light in them. And as you can tell, these pumpkins are fixed colors, but they are changing. So as you can tell, this guy is changing color, and this guy is changing color, and every single one of these guys are changing color. So this could be, obviously you're not going to use them for pumpkins, but what you can use them for is like decorations in the background, or maybe Christmas tree lights, for example, that kind of had the same thing. It's just the speed that differs from this one. So that speed would be way faster, the flickering speed. And also we have random colored street lights, which is some time to time they're going to flicker. And this is basically all what you would need in terms of decoration. I would say. So if it's not a main game mechanic, but you just want to decorate your scene and you want to have some variations, and you don't need to have full control over it. You can have it randomized. You can have it a little bit of random. You can have it dynamic a little. Then you definitely need these things, but I don't think you need any more anything else here. So let's jump into these and let's see how can we create every single one of these. All right. Well, I definitely think the easiest one is the random light that is going to flicker over time randomly, which is basically if you open up this blueprint here, then you can see that this has a static mesh and also a light, which is a spotlight. And now we do not want to change anything on this light, maybe the attenuation and the cone angles and maybe the source if you want it softer or harder. So those are the things you want to change, but not the color because we don't need it. We want to set it to be random, right? So how do we do that? So if you go to the event graph, then you can see this is a really simple thing. We have an array, a color array, where we can set up our own colors, what we want to use for this matter. So as you can tell, I have set up the main colors here in this random array. So how this works is that we have a random array with elements in them, right, in it. And from this array, we are going to get a random element, and then we are going to use that as a color here. So what you have to do is to create a new variable, which is going to be called like random colors. And then here, when it says Boolean, you kind of want to scroll it down. You want to type color, and then you want to choose the first one. Then you want to choose array compile, and then you can add your own colors here. So if I add these colors and maybe white and maybe, I don't know, this yellow color, then, and if I change this here, then you can see that it's either going to be black, which is basically just no emission, white or yellow here. So as you can tell, now it's white. And if I do it again, it's black, so there's no emission. And if I do it again, it's black again. So now you can see that it's working and it's choosing a nice yellow. And so now it's choosing from that array. So have an array set up here. And then you just basically drag and drop that. I'm gonna just delete everything else here. So we created this array. We are going to drag and drop it into the scene, and we are not gonna set it but get it. And we are going to get a random array item here, and then we are going to here we're going to drop the spotlight, drop in the spotlight. We're going to get change color or light color, yes, set light color right here. We are going to plug this in, and the new color is going to be our random item, and it's going to convert it. So we have to organize it a little bit, but as you can tell, it's working just fine. So now we solved the random color issue. How do we? So every single time that we play this game, we are going to have a random color here, but we are not going to have flickers. So how do we get flickers? Well, we create a custom event for it. How you can do that is basically just come to an open spot here. You press tab and you just type custom event. We add it, and then we can rename it. And then we can name it like flickering lights, for example. And how the flickering works is a little bit, let's say it's not complicated, but it's a little tricky. So what it does is we are going to get a random integer from 0 to 10. So it's 11 numbers. And if that, we are going to check that number every time we fire up this, custom event, we are going to get this number, this random number from 0 to 10. And we are going to check if that number is bigger than something. And this is going to be are we going to flicker the lights or not code, basically. So this is maybe the frequency of the flickering. So how many times it's going to flicker, how frequently it's going to flicker. So I set it up to 8. So every single one of the number that I get is going to have to be more than 8 in case I want the lights want to flicker, right? And so obviously the smaller this number is, the more frequent the flickering will become. So not the frequency of it, but the the frequency of it basically is going to flicker more times. Um, so it's not going to flicker like every 5 seconds, but it's going to flicker like every 2 seconds, maybe. It's going to determine, we're going to determine that here. So if I drop this down to 1, just to understand, then we have a really great chance of this random number to be greater than 1. So then it's going to fire up the true, which is basically the flicker animation here, or the flicker part of the code here. So now everything should flicker every 5 seconds. Or mostly everything should flicker. We never called the custom event here, so we gotta call it. So we made that flicker light custom event. You gotta call it then in the beginning. So now everything is flickering, and then after 5 seconds, which is like right now, everything is flickering again, or most of the lights are flickering again. So this is how you can make it. It's really good for horror games, maybe, or like uncanny environments where you just want to have that feeling of like uneasiness, to have the lights, to have some lights flicker. But I do not recommend you use it like very often. So I put it to 8, something like that. So it's going to have like a 20%, or maybe, I don't know, 25% chance of flickering. But I don't know if my math checks out here, but like a low percent, right? Or maybe if you want to have like exactly 20%, then you can have like a max of 4. So it's 0, 1, 2, 3, 4. So that's 5. And if it's greater than 4, not 4, sorry, it's greater than 3, then it's going to be a 1 in 5 chance of the lights flickering, and that's 20% maybe. So that's on you. So with that, we're going out of the true or the false side of this. I'm gonna go out on the true here. So if the random number is bigger than what we set up here, is bigger, then we want to flicker the lights. So what do we want? We want a for loop, because we want the lights to flicker a number of times. And that can be set by, you just place a for loop here, and then you say the first index is going to be 0 and the last index is 5. Now, the problem with this is not random. Every single time the light is going to flicker, it's going to flicker exactly 5 times. So ta 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 ta. And we don't really want that. We want some variations. Maybe we just want a short flicker, like an on off, or off on, and maybe we want a longer flickering sometimes, or time to time. So we kind of want to have some randomizations here. But the thing with the for loop is, if we are going to connect a normal for loop without a delay, then we're not going to have the last index, or maybe it's going to do the for loop like instantly, because we do not have delay in it. So it's going to just fire it like 6 times. So you're gonna only see like one off and on the light. So there's not going to be like a long flicker. So what do we have to do is to create a for loop with delay, which is really easy. I'm going to show you how to do that. So if you probably if you are making a game, you probably have this one. You just right click somewhere, you create a folder called like function library or something, and then you come to your blueprints, and then you create a macro library. And then every single new macro you make, you have to open this new macro library up, and then you create your own macros that you can use in blueprints. So for example, I have only one macros here for the sake of the tutorial, and this is the for loop. So if I double click it, as you can see, this is a for loop with a little bit of change, that it has a duration and a delay. So now the easiest way you can do this, you created this macro library, you opened it up, you pressed add and the new macro, right? And then you will have this here. So what you have to do is, wherever you are in your project, you just get a for loop, a normal for loop, not with a break. or maybe with a break if you want that, but a normal for loop. And then you double click it, it's going to open up the macro of the for loop, right? And then you're going to copy everything from this. So sadly, I never found a way to why isn't it pasting it here? Okay, so I never found a way to copy the inputs and outputs, so you have to do that yourself. So here we have, if you click on this, then you can see the inputs and outputs. So we have an exec, 2 integer, and on the outputs we have 2 execs and 1 integer. So we do that right here. We had 3 inputs here. We want an exec. We want 2 integer. And then we want 3 outputs here as well. We want 2 execs and 1 integer. Right here. And now we can name these, right? So the names for this was execute. So if you type execute here, it's going to remove the name, which is really nice because my OCD is like really fucked up when it comes to nodes. So we get a first index, we get a last index, and then for the outputs, we have a loop body, we have an index, and then we have a completed. So here you can see the same thing. And now this is a basic for loop. I'm going to show you how to connect everything here, but you can always just click on the original for loop and connect everything how this is. So we go to inputs to assign, false to completed, and then to loop body. Now we are going to variable to value here, and let me double check myself. So, and index, yes. So we're going to use the index here, like that. So now it's going to work. This is our new macro, which we are going to call for loop with delay. That's how I call my original one, but this is I'm going to call YouTube for loop. And now we are going to test it. We are going to get maybe open up our third person to test this thing, and then event graph, and whenever I press whenever I press maybe F, then I want to, so you type YouTube for loop or like for loop with delay. I want to have like 5 times or 6 times print hello. So it's going to print hello every single time I press F 5 times. So let's see. So that's 1. So it's not working. So we connected something to the wrong place. Oh yeah, we never connected the first and the last index, so that might have an effect in that. So the first index goes to the value. So that was so the variable. So no, the value. Okay. So the value was the first index, not the variable, and the last index is going to be here. Yes. So that's that. And now that we connected it properly, we can try it. It's a really great skill to, or it's a really great habit to have to check yourself. So now we have 6 hellos, which is not what we wanted, or maybe it is. Oh yeah, it is, because we have 0 to 5, which is 6. So now we have a functioning for loop that we created, we copied from the originals, and now we can modify this a little. And why do we modify this, by the way? Because you can't really modify the standard for loop. Maybe if you have like a C++ experience, then you can open up that file and like modify it, but we can't, because I'm stupid for that. So we are going to create a macro that does the same as the for loop, and then we can modify that, because now we can place a delay here. So we place a delay, and we are going to connect the then one to the delay, and we are going to connect the assign to the delay like that. And now, how do we control the delay? Because it's every time it's going to be 0.2. We create another input here, which is going to be a duration, delay duration, or maybe just call it delay, so it's nice and fancy. And then you don't want an exact pin, you want a float pin here. And you just connect it to the delay. So now, if we go back, we have a delay here. And if I press 0.5, every half a second is going to print hello until we have printed 6 of them. So just like that. So this is how you can make a for loop with delay. And this is good for us because it's not going to fire all the loop bodies in the same time, but it's going to have them a little separately, or fire them a little separately from each other. So let's go back to the light pole blueprint that we just created, or the light blueprint that you have. And it's basically this macro that we just created right here. So if you press tab and you type for loop, then you can see that you have 2 macros here, or I have 2 macros here. You're gonna have 1 macro here, which is for loop with delay. Then you just click on it, and then you just plug it in. So we're not gonna bother with the completed tab. So I'm just gonna disconnect that. So what do we have is we want the light to flicker in a number of times, but we want that number of times to be random, right? So what I have set up here is a random integer in range. So just tab random integer in range. And then what you can set up is to have the minimum and the maximum of that integer. So what's it going to be? It's going to be between 2 and 6, but it could be between 2 and 10 if you want some really long or really just many flickers, basically. Then you can set it to like a higher number. So now this is what we want the last index to be. We always want the first index to be 0 because we want it to count to that number, right? So it's going to be the number that we get here minus or not plus 1. So we connect it to the last index, and then we set the delay to 0.15. What I found is that if you set it anything below it, then it's going to skip some bodies. Maybe it's because of the tick rate, or maybe it's your FPS, or I just don't know. But if you set it to 0.15, it's going to work just fine. So now every 0.15 seconds, it's going to fire up something, which is basically get the spotlight here, and then we want to set the intensity because we want it to flicker, right? And we do not really want to set it to 0 because when lights flicker, it doesn't really turn off. It's just going to decrease its intensity, right? So it's the luminance is going to be dimmer, the light is going to be dimmer. So I have the minimum to 0, which is basically off, and the maximum is 0.2. Again, a random float in range, and then we are going to just connect it to the new intensity. So it's every time it's going to flicker, it's going to get a number of between 0 and 0.2. And this is going to be, sometimes it's going to turn off the lights completely and turn it back on, and sometimes it's going to just dimmer the lights, which is real nice for atmosphere. So we have that, you connect it, and then with a little delay, so 0.1 seconds, we are going to turn it back on to the original intensity here, which is 8 for me because I'm using this setup here. So that's basically it. You just copy this here and you type 8 or 5000 if you're using lumens, or it's basically what you have your light set up. So you gotta use that one, obviously. So your numbers will maybe differ. So now we have the flickering part, but what do we do when we are not getting that number? If the number is less than 3, then it's not gonna flicker. Then we are going to have a 5-second delay, or a 10-second delay in your case, or a 2-second delay, and then we are going to fire up this custom event again because we want to check it again if we get a bigger number of this one. So this is basically how frequently do we want to try to flicker, and this is basically are we successful with the flickering? And if yes, then flicker the lights. If no, then try it again in 5 seconds, 10 seconds, what you set up here. And from the completed, we want to connect it again, because even though we were successful and we did flicker the lights a number of times, we don't want to end it here or end it there. We want to get the completed and connect it to the delay, because then after we successfully flicker the lights, after that we want to check it again in 5 seconds that we can or cannot flicker the lights. This is basically it. This is a really simple blueprint, but it can have a really great impact on your game when you're just maybe you have a horror game with a bunch of like side lamps, and those can flicker and give you heart attacks. All right, so pumpkins. Pumpkins is kind of easy. It's a little bit more difficult than the other one, but it's kind of easy. So here's the thing. Pumpkins work like this. So this light works like this. It gets a random color in the beginning. So as you can see, we get a point light, we get the set light color, and then we split the structure here. So if you right click here, you can see this is the base node, and then you can just right click on the blue one and then split struct pin. And then you can basically just have different random floats in range connected to the RNG and B, and then you will have a fully randomized color. Now, why is it bad? It's bad because it can be white, it can be black, it can be, maybe it cannot be black, but like it can be white, and we don't really want that. So what I recommend is you doing or you making an array with the colors that you kind of want, right? So you do that, and then you just plug one random in. Now we need another array. So this is the same array, by the way, that we had in the light pole one. So you can just copy and paste it here. And then we have another variable, which is the random color here, and that is going to be which random color it has to blend to, right? So you just make another one. Is the same as the random colors array, but it's not an array, it's just a single variable here. So now that we have those two variables, after we set the random color light, so when we press play, it's going to be a random color. Then we want to set this new random color to something. Now this can be, again, you can just split this structure, and then you can use the same thing here. But with the integers, it seems like, so it's 255 is the max. So in integer in range 0 to 255, which is going to be the RGB number. And then it doesn't matter. I set it from the random colors. The thing is that it has to be set, because this is what is going to be the target when we are blending two colors. And then we call our custom function, which we haven't created yet. So you just tab, and then custom event, not function. I'm always saying function. So custom event, and then you just name it. I named it change color over time. How does this function work? Well, now this looks like a fucking spaghetti code, but don't worry, it's going to be, everything is going to make sense. So it's a really simple one. We have a lot of cool things in our Unreal Engine, which helps us like a bunch. So for example, the interpolate nodes. So we have a lot of interpolate nodes. We have vectors interpolating. We have floats. We have it transforms. We have everything interpolating. And this is really nice. It's really easy this way. So the main thing is that we want to set the light color to something else. So we get a set light color node here, and then we basically just plug it into the function, the custom event. However, we want it to set this color over time. So how do we do that? We create a timeline, because that's what controls time. So we just timeline, add a new timeline. We name it color change. I name it 2 because I already have one. And now this is going to determine the length of the blend. So if I create a new float track, and then I set the length to 3 seconds. This is in seconds. Then the change between the swap between two colors is going to be exactly 3 seconds. So from red to blue, it's going to slowly blend from red to blue in 3 seconds. So um, I set it to 5 because I like it to be slow, but if you want it to be faster, then you set it to for example, 1. And then we can try this one, by the way. So add the new key, so right click, add the new key, and again, right click, add the new key. And then here you can just set the time to 0 and the value to 0. And then you can set the time to 1 or 5 in your case, or 3 in your case, which is the length of the whole timeline here, and the value to 1. And now we have our timeline, so we can just close this out. As you can see, if we open this up, it's the same thing. I just have it set to 5 seconds. So, oops, I just closed it. So we have this timeline. We plug this custom event in from play from start. That's all we need to do, basically. And then, as I said, we have a lot of nice interpolate nodes here. So what we want to look for is interpolate, and then you can see that linear color is an option here. So we choose that, and then you can see we have two two options here. One is the current color, which is basically you get the point light and then you get light color like there, and then you plug it to current, right? So that's going to be our light color here. I don't know why there was a convert node there, but whatever. So this is our light color. We get the current light color, and then we want a new random light color. And you can do this new random color here that we set here, which is basically the same thing. I just have a little more, I don't know, visually it's better to understand it this way. But what you can do is just to get the random colors here, like that. And then just get a random array item and then just plug it into the target, and then it's just going to convert it, and it's the same thing basically. I just like to have it in a different variable, which I do not know if it's bad for if it's bad for performance purposes, but I think it's just, if it's one thing that helps you visually understand it, then you have to use it, or you should use it. So this is basically, we want to interpolate from A to B. Which what is A? A is the point light color, and what is B is the random color that we want from the array. So and then the return value is going to be the new light color, and we want this to be over time, and this is why the interpolate node is so fucking nice, because then you can just set the speed to 1, or I don't know what the speed was on the other one. Let me just check. It was 1, yes. So we can just basically set the interp speed to 1, and then the delta time is what we are going to use for the color change that we created. Oh, by the way, if you don't want it to say a new track, you just open it up and then you just rename this here to whatever you want. And then with that, it's going to say whatever you want, and then you just plug it in. So you gotta use the data time, that's it. And with that, if we did that, we basically, this is on the update side, by the way. So it updated the new color. So let's say we have finished it and we have the new color. Then from finished, we are going to get a delay, because we don't want the software to scramble things together. So I usually set up a delay just for the processor to have more time to process, and everything has more time to process, and it's just nicer. So we have that, we had the delay, and then we set the new random color, because we now have that new random color variable to whatever the color is right now. But we do not want that, because then it would be interpreting from blue to blue, and it just doesn't make any sense. So we want a new random color. So we basically just set this random color to a new random color, and then we call the function again, and it works, and it's awesome and cool. And let's see it in action. All right, so now it's yellow, and then it's going to get to orange-ish, all the way to again yellow or maybe green. It's basically green. Yeah. Okay. And now it's blue. All right. So let's get into today's big ass topic, which is the how to do this whole thing with on your materials. And I'm telling you, this is not the right way to do it. So the right way is to have them in a blueprint, and then you can code in it, and that's the right way because then you have more control. Let's open up just one maybe here, and we can open up their material. Um, so not this material, by the way, but this material. So now this is the whole material that makes these lights kind of um, have these random colors. So it looks a bit strange for you for first, but like bear with me, it's really simple. So we can separate these. Whoops, we can separate these by three parts. So first part is the alpha channel, which we are going to talk about later. But just so you know, we have an alpha channel here. So we can just separate this. This is basically controlling the blend between two random colors. And this is the two random colors. This is one random color and this is another random color. So first, let's talk about how can we achieve a random color here. Well, a random color in vert space is to basically just get the object position, which is going to give you a number, and then run it through a sine node. So I'm going to show you what that does. If we have the object position, which is a stab object position, in vert space here, like that, then we can plug it into emission color. And then if we apply, as you can see, everything is fucking right. If we run this through a sine node, then you can see everything has a different color. Now, how can we change this different color? Because the whole thing is that we want it to be interpolating from one to another, but we gotta specify as in the other case, we have to specify what is the other color, right? So the way it works is that we have to multiply this. So this is basically a number. You have to think about this as a number. So if you multiply that number, we get a sine node. We multiply that number. You can tell that this is green and this is white, right? Or this is the closer one, and that one is blue. So what we can do is that multiply this by 300, maybe, I don't know, and then you can see it changed color. So now it's not green, it's not white, and it's not blue, right? It as the way you can think about it is it's offsetting the object in vert space without offsetting it in vert space. So it gets the vert space coordinate and then it's going to offset it by a number. But the way you can use add, why I use multiply is because it's going to have bigger differences. Because if you have a coordinate that is 200 and 201, then it's not going to be a really big change in color in between those two. But if you multiply it and if you add 50 to that, then it's going to be 251 and 250, which is still not a big change. But if you multiply that with 201 and with 200, then you can get like a 200 difference between the two. So it's a bigger difference in color. So that's why I use multiply. So now how do we make it blink or flicker? Well, as you can see, we add time to it, and the other tutorial I did the same. We get time, and then we basically just have a control of the time. So we multiply the time with something. I'm not going to use anything here because I want it to be the real time here. And then we add these two together. We add time to the vert position, and then we run this through a sine node as well, which is basically going to be this one. Now, this is the speed, how you can, so the speed of the sine flickering is the time speed. So if I decrease it to 0.2, then you can see that it's going to be 5 times slower. Now, whatever fits you or whatever floats your boat, you can use that kind of number. And now we add this back together, we multiply this back together. So then, as you can see, we have nice color variations. Now, the only thing that that sticks out is that we have black boards or like signs here, which is like bullshit because we don't have a black light, right? So what do we do? The sign, how the sign works, which I didn't really understand back then when I made that other tutorial, is that it's going to have a -1 to 1 in a wave like that. It's going to go from -1 to 1 to -1 to 1 to -1 to 1. Now, we do not want to have a negative number here because negative numbers in terms of fucking light is going to be dark. Like it's going to, um, uh, it's not going to be emissive. So we want only positive numbers. So how do we get positive numbers? Well, we have whatever negative number we get, we had their absolute. So if we get negative 0.5, then we get the absolute of that, which is 0.5, which is basically just the flipped to the other side of the graph here. So we get the ABS node, which is the absolute, and then we plug that in. And if you pay attention to the, I'm going to just make this bigger for you. If you pay attention to the black cards right now or black boards right now, then it's going to just disappear and have their opposite effect in theory. And I think it works. I don't know why that doesn't work, but I think it's just we never apply the material to it. Hopefully. So now that's that. We fixed that kind of problem. Now we have another problem, which is we only have this board. We only have this board to have the green, not green, sorry, to blue to yellow color, and it has this purple-ish fade, right? So it's going to blink this only these three colors or only this color range, but we do not want it to have only this three. So we create another profile for this, which we offset even more with the multiply. So you basically just, I'm gonna just delete this. So you basically just copy this and paste it again, and then we offset it not with 300 but with 20. So you have a big difference. So now if I plug this in, as you can tell, it's again blue and orange, blue and yellow and purple. Now if I apply, then as you can see, we have the same thing for some fucking reason. Okay, yeah, I just had to a little shift it. So now we have a little more colors in it, but we want some different colors. Now we have like green-ish colors, we have purple. So now we have another, and we don't have blue anymore. So we decrease this even more maybe. And then or we make it really big. And now we have like yellow, red, and green as of and not. So now we have yellow, red, and green, and not blue and purple and yellow. So now we have other colors added to it. We can maybe change the speed of it. We can maybe have it to 1. Like that. Not 0, 1, but 1. Like that. So it flickers a little. And also, so we have now the two color profiles here, which are random colors. And then now we can make a mask that will blend, that we will use to blend between these two. So how do we do that mask is the question here. Well, we do the same thing, basically. We get a vert position, we multiply it by a number, we have a time to set to x, and then we add this back together, run it through a sine, and then we use a desaturation. I'm going to show you why. So we have a sine here. We made this. Let's see what this does. So what we need is a black and white mask. So now what we have is just we are going to only pay attention to the brightness colors here. As you can see, the brightness is changing. It's not that noticeable here, but if I use it on 1, then you can see that the brightness is changing, by the way. So if I undo this like that and use a desaturation here, and I don't think I ever touched the fraction of it. So it's going to be default, right? Yeah, okay. So it's a default desaturation color. Then you can see we have only the brightness map. So like we have the -1 and the positive one. which is what the sign does basically, but we have more control over it, and it differs. The speed of it differs each sign. So it's not, because if we don't use this, we just use a sign, then maybe time sign, then as you can see, it's going to have the same thing for every single one of the signs here. But we do not want that. We want to have different blendings. So again, it's the same thing. Now we have different sign speeds. I think this is really slow. Yeah, this is more like it. So now this is going to be blending between those two colors that we just, and those two speeds that we just made. So how do we do this? Well, I'm going to get a linear interpolate node, which is just if you press L in your keyboard, then you just click, then you get it. But interpolate, then you can get a linear interpolate node here. Which is going to be, A is going to be the first one we created, and the B is going to be the second one we created. This is going to be the mask that we just created. And also we have an absolute here. It's better to have it twice than not have it at all, because then you will have negative numbers. So this is basically not needed here. I just placed it here because I want to be sure. And then I multiply it by a number, which is going to be the strength of the emission. And I created a parameter of it. So basically that's it. Now if we compile and apply it, as you can see that different speeds blinking, different colors blinking, different whole thing, different, everything is just random. And then you can just play around with the times, because now this is something that I wouldn't really use because I think it's too rapid, and I think it should be a little bit laid back. So I would probably spend some time tweaking the time nodes and then making everything a little slower, which I might do right here. Everything a little slower. And this is maybe what I would say is nice for a city. It's not too disturbing. It is still disturbing, by the way, but it's not too disturbing. So if we press play and we hop into the game, then you can see that things are changing differently and randomly. So that's it. And maybe I could give you a little more insight on how this topic works and how these random materials work. But again, I do not recommend you using this. And the reason why is because it's really performance. You will have such performance problems if you have like 5,000 assets in your game, because this, like, you have to remember that you're not only making a game, you're fucking optimizing it in the same time. And now if I pull out an RHI, which I'm going to do right now. Oops. Then as you can tell by just looking at this street alone that I have here has 2,000 draw calls, more than 2,000 draw calls. We're almost at 2,500 draw calls with this only, because every single fucking object here, this one street, this could be a level in your game. So you just don't really want to use it. You want to use instances, and you want to use blueprints, and then you want to use the things I showed you, how to get the random color, how to get it flickering, how to get it blending, how to control the speed of it. So you want to use those, and you don't want to use static objects everywhere scattered around your map, and the color driven by the material and the logic of the game. And like, you just don't really want to do this. So having said that, if you're in trouble and you have to solve it somehow, this is a way to solve it. Don't use it in a game. So thank you for watching. Thank you for being here. Hopefully I could clarify it for you. If you liked it, consider subscribing. More coming up. Goodbye. See you.